Hey guys, today what we're going to be doing is talking about how to find the slope given two individual coordinates. So we have two coordinates plotted on the graph here, and we're going to talk about two ways to do it. We're going to talk about how to solve this algebraically, and we're also going to talk about how to solve this graphically, so that you have two options. We're going to talk about the algebraic method first. So what I like to do anytime I have coordinates, whether I'm working on slope or whether I'm in geometry talking about the distance formula or midpoint formula, whatever it is, what I like to do with my coordinates is I like to label one of them x1, y1, and I like to label the other one x2, y2. Because a lot of formulas we have that talk about points or coordinates are going to have these variables in them. So I label my points with those so that whenever it says x1 or y1, I know exactly what it's talking about. So here's the algebraic formula for slope. It is y2 minus y1 divided by x2 minus x1. So I can just substitute in the values that I have right over here. So when I see y2, I'll go right here and say, well, y2 looks like that is 6. So let's write that. y1, well, right here's y1, it looks like that is 4. And then x2 is 7, and x1 is 3. So I just simply substituted in all my numbers by taking a look at how I labeled those coordinates. Now my formula has its numbers substituted in, and I can just, solve it like I would any other expression. Let's go ahead and subtract these. 6 minus 4 is 2, and 7 minus 3 is 4. So this tells me my slope is 2 over 4. Well, sometimes we can reduce those numbers, those fractions, or maybe it's a number that we can just divide and get a nice whole number for. In this case, 2 over 4 can reduce. You guys are familiar with that. These are both divisible by 2. And if we divide both by 2, we get 1 over 2. That's our fully simplified or reduced slope. And we did it. We solved it algebraically. Cool. We also can solve this graphically. To do that, we need a graph, of course. Now, I'm using this program right here, Desmos. If you don't use it, it's wonderful. I highly recommend it. But if you're working on this paper and pencil, you might need some graph paper to help out a little bit with this method. But we'll go ahead and plot our points. So I already have mine on the graph here. You can tell 3, 4, and 7, 6. And what I can do is I can trace a way to get from one point to the other, utilizing what we know about slope, which is rise over run. So if I start from my first point, and then I ask myself, how much do I have to rise? How much do I have to go up to get to this point? Well, it looks to me like I have to go up 1, 2 units. So that's my rise. And then how much would I have to run, or how far would I have to go horizontally to get to my next point? Well, 1, 2, 3, 4. So I get 2 over 4. Well, look at that. That's the same number I had down below, right? And yet again, I can simplify this to be 1 over 2, because we want to write it in simplest form. Both of these methods work. The reason both of these methods work is we're looking for how much does it have to move horizontally and how much does it have to move vertically. Like, let's think about this. What we're asking ourselves is how much or how far does this point have to travel up or down in the y direction to get from where it started to where it ended. We're looking for that amount of space as our numerator. How much did it rise? Or maybe you could think of where did it end, the y-coordinate where it stopped, minus where did it began, the y-coordinate where it started. Same thing happens with x, right? We're looking at how far did it run? How far did it have to move in the x direction? Or, where did it end minus where it began in the x. That's why we get the same answer either way. That's why these are equivalent ways of finding it. Well, I just wanted to do a quick video that goes over how to find slope given two coordinates, whether that's algebraically or graphically. Both work well. If you have any questions about this, guys, feel free to let me know. Thanks for watching.